can understand that this is definitely C is for SN2 mechanism. So that's right. Now, if you just think about the A, B, and D, among them, the point is, I guess right now you should realize that the formation of carbocation and the formation of product are not going to have same energy, are not going to happen in the equal, you can say, by the equilibrity. So what is the main governing parameter? First, we need to understand this. So which of the following potential energy diagram? So which of the following potential energy diagram represents SN1 mechanism? Okay, that's the question. So in SN1 mechanism, the first step, the step 1 is the formation of carbocation. So if you just think about it, if I have a 3-degree system, just like this. Okay. So first, what would happen is it would go for carbocation formation. Let's say I have a leaving group over here. If the leaving group is a good leaving group, then it would go for a carbocation formation. Now, guys, if you remember that I told you that why do we call this reaction SN1 reaction? Because the reaction, in the reaction, the rate of the reaction is proportional to only the reactant concentration, right? No, got it. Okay, fine. Now, the rate is only dependent on the reactant concentration. So it's only dependent on this concentration. Okay. Now, in the second step, what happens is the nucleophile comes and gets attached. Now, guys, if I just ask you truly, which step do you think is destabilizing, or which step would take more energy to happen? Or I can say that which step do you think that after the formation of that step, after that step is going on, as a product, whatever it is happening in step 1 or step 2, which product is more reluctant to occur? The step 1 product or the step 2 product? Write it on the chat, everyone. What do you think? Like, which product formation is more difficult? The molecule is reluctant to form that product. Step 1 product or step 2 product? Sanjana and Abdul, right answer. Look, let me tell you something. For the reactant right now, what we have, and the product right now, what we have in the end, all of them are octet configuration, isn't it? So we know that octet configured systems are definitely stable. But if you look at my intermediate, this is 60 configuration. It has 6 electrons. Look into it. 1 single bond contains 2 electrons. We know that. So 3 single bond would contain 6 electrons. So this is a 6-state configuration. No, don't look at the other stability or distability factors. You can see that 6-state configuration, due to the formation of 16 configuration, this product is unstable. Formation of this step is difficult. Whereas this step is stabilizing it. It is neutralizing the positive charge, which is the first thing. Second thing is it is attaining the octet configuration because of 2, 2, 2, and 2. Total 8 electrons are there. Now, because of this only, what happens is the step 1 is the slowest step. We can say rate determining step or the slowest step. It is slowest because it asks for a huge amount of energy because it is not becoming stable. It's just like if I just push you out from your home right now, that's the unstable form you are going to get. You're not going to have your food on the road. Okay, so those things are going to make you unstable. So what I have to do is I have to give more energy for that. Makes sense, right? So for that reason, this step is taking more energy, whereas this step is comparatively taking less energy. That's why the answer should be option. You see that? The first step is taking more energy, leaving the higher energy. but this is my carbocation. This step is taking less amount of time. Clear, everyone? That's the thing. That's the process of solving these questions. Now I think we are clear.